There are a couple of ways of doing this. One thing you can recognize is that anytime you do the zero matrix times a vector x, you get the zero vector back. And you can write that as the scalar 0 times x. So what does that mean? Well, that means that 0 is an eigenvalue. And notice that any vector x then satisfies this equation. So the way to characterize all vectors that satisfy that equation is given by the span of the unit basis vectors. And you have to just keep in mind that the zero vector is not of interest when we're looking for eigenvectors. Now, another way of doing it is to say, take the matrix, subtract off lambda times the identity. Now remember, the identity is just a diagonal matrix with ones on the diagonal. Scale that by lambda, you put lambda on the diagonals, subtract that off of another matrix. All you do is you subtract lambda from the diagonal elements. And if you then ask the question, when is this matrix singular, what you conclude is that lambda is equal to 0. And then once you actually plug that in, you end up with the matrix 0, 0, 0, 0, and you ask yourself the question, for what x is this true? And you end up again with the span of the unit basis vectors. Okay, so let's move on to something a little bit more difficult. Why don't you contemplate what the eigenvalues and eigenvectors of this matrix might be? You will see me in the next video.